Welcome viewers, in this video we will see the starter used in the DC motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the topic. First we will see what is the starter, why we are using the starter in DC motor. Starter is a resistance connected in series with the armature circuit of a motor during the starting period in order to limit the high starting current. So, the starter is nothing but a resistor connected in series with the armature circuit during the starting period in order to limit the high starting current. Now, we will see why we are using the starter, what is the purpose. When a DC motor is started with a full voltage applied across its armature terminal, it draws a more current than the rated value. So, while starting the motor, the armature circuit, it will draw the more current. We will see how it will draw the more current. So, we know that for a motor V, terminal voltage V equal to EB plus IA RA, back EMF plus armature resistance drop. So, that IA can be written as E minus V minus EB divided by RA. So, our aim is to limit the armature current, so that we got the expression for armature current, that is nothing but terminal voltage minus back EMF divided by RA. From this equation, the IA expression for IA is derived. So, since at the instant of the starting, the speed is 0, at the beginning the speed is 0. So, the back EMF is also 0, because back EMF is proportional to the speed and torque. So, initially speed is 0 means back EMF is also 0. So, EB equal to 0. So, in this EB is 0. So, only we have V by RA, terminal voltage divided by armature resistance. Back EMF is 0 because speed is 0 at the beginning. So, the armature resistance of a motor is very small value. This RA value is very small, right? In order to limit the current, already the armature resistance value is very small. Now, we will see the one practical example. Let us consider the case of 220 voltage DC motor with the armature resistance of 0.25 ohm. We already said that this armature resistance value is always very less. Here it is 0.25 ohm. Then at the instant of starting, by using this formula, IA equal to V divided by RA. So, we have taken V equal to 220 voltage, RA is 0.25 ohm. So, by 220 divided by 0.25 is nothing but 880 amperes. So, the armature current during the starting is around 880 amperes. This current is much higher than the rated current. This current will flow through the armature winding, mean it will damage the armature winding, right. So, that is the reason why we are using the resistance. Why the armature current is high means, first the speed is 0, so that back EMF is 0. So, IA is only depends upon V by RA. RA value is very less. If we take V equal to 220, it is nearly 880 amperes. So, it will draw around 880 amperes, which is much more higher than the rated current. So, if the current is flowing through the armature circuit, it will damage it. Now, we need to limit this current. But when the motor picks up the speed and the speed increases, the back EMF also increases. So, the armature current IA automatically decreases, gradually come down to the rated value. So, during beginning only it will draw the more current. If the speed gradually increases, EB will increases. So, due to that IA will decreases gradually and it will reaches the rated value. So, only during there is a problem with a high current. So, we need to concentrate while starting we need to limit the armature current. To limit the high starting current, a resistance is connected in series with the armature at the time of starting, only at the starting, and then gradually cut off, gradually reduced as the motor speed increases. So, our main problem is only during the starting it will draw the more current, so that the resistance is connected in series with the armature circuit during the starting, thereby it is gradually reduces. right? So if the resistor is connected in series, what will happen? Now after introducing the starting resistance Rs, Ia equal to V divided by Ra plus Rs. Initially only Ra is there, this value is very less. Now we connected Rs, series resistance, this value is very high. If the denominator is very high, mean automatically the current will be very low, right? So hence the high current is limited. So by introducing the series resistance connected, this value is very much more, it is available in the denominator, so automatically this numerator value is reduces, current is reduces. The starter is also incorporated with protective device to protect from the no voltage and over voltage, right? It also doing to protective, it also act as a protective device in order to protect from no voltage as well as overload. Now we'll see the 2-point starter. There are 3 types available: 2-point starter, 3-point starter and 4-point starter. In this video we'll see the 2-point starter. So the 2-point starter, the connection diagram is given. So this is the resistance connected in series with the armature circuit. So starting resistance Rs. There are tapping available so that we can increase or decrease the resistance connected to the armature circuit by using the tapping. Now we'll see the diagram. So this starter is used for series motor. Series motor means the field winding and armature winding are connected in series. This is the armature winding, armature rotating part. This is the field winding, stationary part. Both are connected in series. This 2-point starter is used in the series motor. So this is the supply, DC supply is given. So switch is available. The double pole single thrown switch. The fuse is available. This is the line. This is the field. So we have 2-point starter. These two are the points available. Line one point refers the line. Another point refers the field winding. So here we have the one starter handle is available. So by moving the starter handle, we can add the resistance to the armature circuit. Here one hold on coil is available. It's nothing but electromagnet. One electromagnet is there, coil is available. So when the current is flowing through this coil, it becomes the electromagnet, it becomes the magnet. So here the needle is available. So this needle can be attracted or repelled by this magnet, right? So this needle can be attracted. So we have series motor, field winding and armature winding is connected. The supply is given through the switch and fuse. Here we have one starter handle is available. On other side, the hold on coil is available. Now see the diagram. The starter handle is not connected, so that this armature resistance are not connected to the motor. So if you connect this, so this is called the off position. This is the start position. If you bring the starter handle in this start position, what will happen? The entire starting resistance is connected to the motor. So the current will be very less. At this point, the entire resistance is connected. The current is flowing through this resistor, so the current is very, very less. If you slowly moving the handle towards in this clockwise direction, what happened? The resistance are decreases, slowly decreases, so that the current will increases gradually. At this point, the resistance is, starting resistance is very, very high, the current is very, very less. So the motor will draw only less amount of current. So that is our aim. The aim of the starter is to limit the starting current. If we slowly reduce the resistance by moving the handle in clockwise direction, the resistance are slowly decreases, so that armature current slowly increases, right? By moving in this position, at this position, it is called a run. So if you put the starter handle at this position, mean it is connected directly without any resistance, right? So it will draw the full load rated current. Now that the current will flowing through this armature and field winding. So at this point, resistance is more, current is very less. While moving the starter handle in clockwise direction, the resistance gradually decreases and current increases gradually. At this point, the current is maximum, rated current will be given. The resistance is almost zero. There is no resistance, it is directly connected. This point is directly connected. This current is flowing through this electromagnet. So this becomes this coil, so that it is electromagnet. So this bar is attracted by this electromagnet. So it will hold this electromagnet will hold this starter handle. This starter handle is attached to this electromagnet, right? So that the starter handle always available at this position, so that the rated current is flowing through the armature and field. So now we discussed that the armature current is gradually increases by moving the starter handle, and this starter also used to as a protective device for two different purposes. One is, suppose if the load is very less, the load at this motor is very less, what will happen? The current is we need to protect from two different cases. One is when the load decreases, similarly the supply decreases, no load as well as no voltage. For these two we need to protect from the motor. If the load is decreases, what will happen? The current drawn by the motor also decreases, so that the current flowing through this electromagnet also decreases. So it becomes the demagnetized. If the current decreases, it becomes demagnetized, so that it will release the starter handle. So the starter handle will go to the original position, that is off position. If the load decreases, the armature current will decrease. That armature current is flowing through this electromagnet. So if the current flowing through this electromagnet decreases, mean it becomes demagnetized. The starter handle is held by this electromagnet. If the current decreases, it is demagnetized, so that it will release the handle. So it will go to the original position. So the supply is disconnected to the motor if the load decreases. Similarly, if the supply decreases, at the time also same thing, the current drawn by the motor also decrease. Due to low voltage, the current drawn by the motor decreases. If the current decreases, this electromagnet become demagnetized. At the time also this handle is released. So it will release the handle, so that it will go to the original position. So the motor is disconnected from the supply. The starter used for three different purposes. One is adding the resistance, then limit the armature current. Another one, during no load condition, it will this electromagnet become demagnetized and release the starter handle. Similarly, during no voltage condition, at that time also the current is less. Due to the less current, this become the demagnetized and release the starter handle, right? So we'll see the description one by one. 2-point starter used for starting DC series motor. It is used for a series motor. L and F are the 2 points of the starter which are connected with the supply and motor terminal. L is connected to the supply, F is connected to the motor terminal. To start the motor, starter handle is moved clockwise from start to run position against the spring tension, right? So this handle is moving in a clockwise direction in order to reduce the resistance and in order to increase the armature current. The starter is to be held in the run position throughout the operation of the motor. So during the running of motor, the starter handle is at the run position. So this is done by means of hold on coil, that is hold on electromagnet. The current is flowing through this, so that it become electromagnet. So it will hold the starter handle. So the starter handle is attracted by the electromagnet throughout the operation of the motor. When the motor is rotating, the starter handle is at the run position. It is held by the electromagnet. Current flowing through the hold on electromagnet magnetize it, and soft iron pieces in starter handle is thereby held by the electromagnet in the run position. When the current is flowing, it become electromagnet, so that the starter handle is held by the electromagnet. Now this hold on coil also act as a no load release. It is also act as a protective device, no load. So during no load, what will happen? When the load on motor reduces, the current flowing through the electromagnet also decreases, and hence the strength of the electromagnet reduces. So the soft iron piece return to the off position, right? So previously the soft iron piece is held by the electromagnet. Now the electromagnet strength is decreases due to no load. The current flow is due to no load, current decreases, the strength of the electromagnet also decreases. So the soft iron piece is released by the electromagnet and it will return to the off position, so that the motor is disconnected from the supply during the no load release. Similarly, the hold on coil acts as a no voltage release. When the voltage is reduces, what will happen? Current also decreases and strength of the electromagnet also decreases. Hence, the soft iron piece is returned to the original position, off position, so that the motor is disconnected from the supply when no voltage occurs. Right. So in this video we discuss about what is the starter, why we are using the starter, and the operation of a 2-point starter. The starter also used for no voltage as well as no load protective device. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the 3-point starter used in the DC motor. So the starter is used to limit the armature current during the starting of the motor, and also it is act as a protective device. Subscribe the channel for more videos and notification. The soft copy of this material available in the description box is available in the drive. The link is given in the description box. Now we will go to the topic. So the point at 3-point starter is nothing but a adding the resistance. So this is nothing but a series resistance, RS. The tappings are available so that we can increase or decrease the resistance connected to the armature circuit. So this is a series resistance. So this type of starter used for shunt motor as well as the compound motor. The shunt motor, here the diagram given for shunt motor. Shunt motor means this is the armature, rotating part. This is the field coil, stationary part. Both are connected in parallel. So that is called as a shunt motor. Shunt means the armature and field are connected in parallel. Now we will see the diagram. So this is the DC supply is available. It is given through the DP-DST switch and as well as the fuse. Right? It's a normal connection. Here we have the OLR is available, overload relay. This one electromagnet is there. The coils are available. When the current is flowing through the coil, it becomes electromagnet. So that is connected to the spring handle, the starter handle. Here one moving iron is available. When it is electromagnet, this moving iron is attracted, so that this becomes the short circuit. Short circuit means that is given to the NVR. NVR is no voltage relay. Right? We will see this operation one by one. So here we have OLR, so electromagnet available connected in series with the supply. Another end is connected to the starter handle. Here one moving iron is there. When OLR is energized, this moving iron is attracted. So these two terminals are short circuited. That is nothing but it will short circuit the NVR, no voltage relay. Now we will see the other connections. So from the supply, it is given to the starter handle, right? So at this point, if the starter handle is placed at this point, the entire resistance is connected, right? Other end, it is going to the armature. So the full resistance is connected, only limited current will flow. The supply is given through this resistor, so the voltage will be dropped, only limited current will flowing through the armature. If the starter handle is keep on moving in the clockwise direction, so this is a start position, while moving clockwise direction, the resistance decreases, so that the armature current increases. At this point, while moving at this point, this supply is directly connected to the armature. All the resistors are reduced, so that it will take the rated armature current. Right? So the during beginning, it will draw only limited amount of armature current. That is our aim, to limit the armature current. We are using this starter. So by slowly rotating this starter handle in clockwise position, the armature resistance slowly decreases and armature current slowly increases. So at this position, it will take the rated armature current and motor will rotate. So this is the soft iron piece is there. So here is a no voltage relay. is there, it is energized, so that the soft ion is attracted by this NVR relay, so it will hold. So the starter handle is, the soft iron piece is attracted by the NVR, so the starter handle always placed in the run position during the rotation of the motor. During the operation of the motor, the starter handle at the run position, that is this electromagnet attract the soft iron, so that it is held in the run position. Now we will see this NVR where it is connected. See, this is connected to the field winding. The coil in the no voltage relay is connected to the field winding. So this one end is connected here, another end is connected to the beginning of the resistor. Right. So now we will see what is the function of this NVR and what is the function of this the OLR. First we will see the NVR, no voltage relay. So it is connected through the field winding. Right. So the first one, if the supply voltage is low, right, when the supply voltage is low, there is no voltage is there, then what will happen, the current drawn by the this current flowing through the field winding also decreases, so that the strength of this magnet will decreases, so it become demagnetized, so that it will release the soft ion. The soft ion is held by the electromagnet, while demagnetizing what will happen, it will release, so that the starter handle will move from start to run to start position. It is disconnected, the supply is disconnected to the motor even during the no load, no voltage condition. If the low voltage is very less, what will happen, the current flowing through the field winding decreases, so that this become the demagnetized, this already electromagnet is demagnetized, so that it will release the soft ion piece, so that this goes to the original position, off position, the supply is disconnected. And another operation of this NVR is, suppose if the field winding is open, the field winding always should be in a closed condition in order to limit the speed. If the flux is 0, the speed will be is infinite, dangerous, right. N is directly proportional to 1 divided by pi, both are inversely proportional, so the always there should be some flux will be there. If the flux is 0, speed will be infinite, the motor will run at the dangerous speed, right. So if there is any open circuit in this field winding, what will happen, this field winding is connected to the no voltage relay. So if any open in the field winding, there is no current flow in the NVR, so that it become demagnetized. At the time also it will release the soft ion piece, so the starter handle will go to the off position. So during entire running condition, the soft ion is held by the electromagnet, it is in the run condition. During abnormal condition, it will release the soft ion piece, so that the starter handle will go to the original position, that is it disconnect the supply, the motor is disconnected from the supply, right. So this NVR doing two different operation. One is when the supply side, if the voltage reduces, the current drawn by the NVR reduces, it become demagnetized, so it will release the starter handle, so that motor is disconnected from the supply. Another one, if the field winding is open, any chance for any possibility of opening of field winding, at that time also the current flowing through the electromagnet is less, so that it become demagnetized, it release the soft ion piece, starter handle will go to the original position, so the supply is disconnected, right. We have another one, OLR is there, overload relay. Suppose the motor draws the more amount of current, already we discussed the no load, less voltage is there. Now over voltage, if the over current is flowing through this electromagnet, what will happen, and through the coil, what will it become electromagnet. So this iron piece is attracted by the OLR. If iron piece is attracted, mean this terminal is short circuited. These two terminal connected in the NVR, no voltage relay. If the NVR terminals are short circuited, mean it will become demagnetized. There is no current flow, so it demagnetized. At the time also it will release the soft iron piece of the starter handle, so that the supply is disconnected from the motor is disconnected from the supply, right. So during overload, more current will flow through the OLR, so it become electromagnet, so that will attract this iron piece. When it is attracted, this terminal is short circuited, that means that the current flowing through this NVR is short circuited, so that there is no current flow, it become demagnetized. So it will release the soft iron piece of the starter handle. So the starter handle will move from run position to off position, so that the supply is disconnected to the motor, right. So here this resistors used to limit the armature current, slowly decreasing the resistor, the armature current increases. That is the main function of the starter, to limit the armature current. Another three functions also available. One is, if field winding is open, at the time this NVR will act as a NVR will protect the device, protect the motor from the damage, and also no voltage as well as over voltage. All the three functions also done by this starter. Now we will see the description one by one. 3-point starter is used for starting DC shunt and compound motors. L, A and F are the 3 points of the 3-point starter. The hold on coil or NVR, no voltage release, is connected in series with the shunt field. We already discussed, it is connected in series. The function of NVR is that when the supply voltage is low or there is a failure of supply, current through the NVR reduces, and so that its strength is decreases, and hence the starter handle is returned to the off position. Another function of NVR is that in case of disconnection of the field, previous one no voltage or low voltage, now there is a disconnection of field due to the internal failure of the control arm, the starter return to the off position, hence the protect from the motor from overspeeding, right. So the NVR doing two different function. One is, any problem in the field winding or the supply voltage is less, at the time it will release the starter handle to original position and disconnect the motor from the supply. Now we will see the overload protection is incorporated by means of the OLR, overload release. OLR is an electromagnet, is connected in series with the armature. It is connected in series with the armature. When the motor overloaded, it draws a high current. This heavy current flows through the OLR and it gets energized. Then pull the iron piece upward so that it is short circuited. Short circuit the coil, hold on the electromagnet. So NVR is de-energized and starter arm return to the off position. So the motor is protected from the overload. So this is OLR used for overload, over voltage. If over voltage is there, it will protect the device. It is seen from the diagram when the starter handle is at run position. During the entire operation, the starter handle at run position, the field current has to travel through the portion of the starting resistance. So during that, the starter handle put in the run position, but it is connected through the series field winding. So the entire field current is flowing through the starting resistance from the armature circuit. This is result in the slight decrease in the field current. This field current is flowing through the armature, this starting resistance, so that there may be a possibility of decrease in the field current. So the field strength will decreases, right. To avoid this can be reduced by using brass arc as shown in the diagram. In the diagram, one brass arc is available. So during the running position, the current is flowing through the brass arc. So this is nothing but a brass arc. So after the motor is rotating, we can transfer the control from this resistor to the brass arc, so that the current is flowing through the brass arc. There is no limit. If the current is flowing through this arm, this starting resistance, the field winding field current will reduces, so that it will reduce the field strength, right. So during the running condition, we can control the transfer to brass arc, so that the entire current will flowing through the field winding, so that we can increase the field strength. Now we will see the some disadvantages available. While controlling the speed of the motor above rated, field current is reduced by adding an extra resistance in series with the field winding. Suppose if you want to go for a above rated speed, we need to reduce the field current by adding the resistance. but the NCR is in series with the field winding. This NCR is connected, no current relay is connected in series with this NCR is connected. When the field current reduces, the current through the NCR also reduces, so that it is demagnetized and starter handle return to the original position, off position, right. This NVR is connected, no voltage relay is connected to the field winding. So, for a above rated speed, if we want to reduce the field current, we need to add some more resistance. So, while adding some more resistance, field current decreases. This NVR, not NCR, is NVR, no voltage relay. The current through the no voltage relay decreases, so that there is a possibility of the demagnetizing the NVR and the starter position return to the off condition. So, effective speed control, field control cannot be done, right. So, that we can go up to rated speed only, we cannot go for a above rated speed. The field control is not effectively done. In order to avoid this, 4-point starter is used. In 4-point starter, the field winding is connected separately, not in series with the NVR, right. For that purpose, we are going for a 4-point starter. So, in this video, we discuss about the operation of 3-point starter in order to decrease the starting current, as well as it is used for no voltage, over voltage and field, any problem in the field winding. It will protect the motor from the this protective, it will also act as a protective device. Some disadvantages available, the field winding is connected in series with the NVR. In order to avoid that, we can go for 4-point starter. For 4-point starter video available separately, the details available in the description box. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the 4-point starter used in the DC motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we will go to the topic, 4-point starter. It is used in the shunt motor, DC shunt motor, 4-point starter used in the DC shunt motor. The video for 2-point starter and 3-point starter available separately. The link is given in the description box. Now we will see that it is used in the shunt motor. Shunt motor means this armature and field are connected in parallel. This armature is a rotating part, field is the stationary part, both are connected in parallel, so that is called a shunt motor. Here we are using the 4-point starter. So, the 4 points are L1, L2, A and F. L1, L2 is the line 1, line 2, A is the armature, F is the field winding. I will see that here the DC supply is available. It is connected through the DPST switch and the fuse. Here we have the OLR, overload release. Here one electromagnet is available, the coil is winded, the supply is directly connected in series with that. If the current flowing through this, it becomes a electromagnet. So, that is connected to the starter handle. It is another end is connected to the starter handle. Here one moving iron is available. When this OLR become electromagnet, this moving iron is attracted. This moving iron got attracted, so that these two terminals are short circuited. That is nothing but the terminal available in the NVR is short circuited. If it is short circuited, this NVR become demagnetized. We will see what is NVR, what is the connection, we will see later. So, this OLR is a electromagnet connected in series with the supply. So, when the current flows, it become electromagnet, then it attract the moving iron, that will short circuit the NVR. So, this become demagnetized. So, one connection. Now, we will see that the important thing is the starter is nothing but we need to add the resistance in series with the armature winding. So, this is the starting resistance RS. RS is the starting resistance. Our important objective is to add the starting resistance to the armature in order to limit the armature current. Right. So, there are such tappings are available. So, this is the start position, run position. This is the starter handle. Here one stopped ion is available, that is attracted by this NVR. During running condition, this stopped ion is attracted by NVR, so that always are available in the run condition. So this end is connected to the armature. The supply is connected through OLR, then starter handle through the armature resistance, starting resistance, that is connected to the armature winding A1. And one more, it is connected through the brass arc to the field winding, and another is it is diverted through NVR. So the starting current having three different paths. One is through the starting winding to the armature, through the brass arc to the field winding, through the NVR another current is flowing. Three different currents. The starting current is divided into three different paths. Here the field winding is connected to the parallel to the NVR. It is parallel to NVR. So any change in the field current will not affect the operation. The operation of NVR will not affect the field winding because it is connected in parallel. In case of 3-point winding, it is connected in series with the NVR. So any change in field winding, that will affect the operation of the NVR. Here it is not affected because it is connected in parallel. Right. Now we'll see this one by one. First objective is to add the starting resistance and to limit the armature current. So when the supply is given, it is flowing through the switch and fuses. Initially the starter handle is in the off condition. When it is placed in this starting condition, the entire resistance is added to the armature winding. So resistance is more, so the current flow is very less. So while moving the handle slowly in the clockwise direction, the resistance got decreases. So at this point, this much of resistance decreases. So while decreasing the resistance, armature current slowly increases. So while going at this point run, the resistance is completely reduces, slowly reduces the resistance, and so that the armature current slowly increases. So it will flow at the rated armature current will flow through the armature winding. So that is our main objective. Initially the resistance more, current is current is less. The resistance is slowly reduces by moving the starter handle in clockwise position. So the resistor decreases, armature current increases gradually and reaches the rated value at this run condition. So at that time the current is flowing through this NVR also. So it becomes electromagnet. So the soft ion is attracted by this electromagnet. So the handle is always in the run condition. During the normal operation of the motor, this NVR attract the soft ion and the starter handle always in the run condition. Then this starter also used for no voltage protection as well as over voltage protection. We will see that how it is possible. So this brass arc is used that. So if the field winding, the current is flowing through the brass arc, so there is no drop in the resistance. If the current flowing through the field winding decreases, the current flowing through this field winding decreases, the field strength will decrease. So that is the disadvantage in the 3-point starter. Now it is the field winding is connected through this brass arc, so the field current will not decrease, so that there is no decrease in field strength. Now we will see that if the load increases, in the motor, what will happen? The current through the motor also decreases, so that the current flowing through this NVR decreases, so that it become demagnetized. So the soft ion attracted by this magnet is released and the starter handle will go to the off condition. That is, the supply is disconnected to the motor. So during no load, during the load decreases, current will decrease. Due to decrease in current, this NVR become demagnetized, so that the soft ion is released. So the starter handle will move from run to the off condition, so that the supply is disconnected to the motor. So it will act as a no load relay. Similarly, if the any open in the field winding, at that time also the current decreases, so that this NVR become demagnetized. At that time also it will release the so starter handle, so it disconnect the supply from the motor. Motor is disconnected from the supply. So we can protect from no load as well as field winding. Suppose if overload is available, the overload, the over voltage, if any over voltage across happen, what will happen? This more current will flow through the circuit due to over voltage. That over current will magnetize this OLR, electromagnet. So become electromagnet. So once it is electromagnet, it become magnet. This moving ion is attracted. So it becomes short circuit. So due to short circuit, the NVR also short circuited. So current flowing through the NVR decreases and it become demagnetized. So the soft ion piece is repelled and the starter handle moving from run condition to start condition, that is off condition. So the motor is disconnected from the supply. So it acts as a over voltage protection also through the OLR. So we can do the, we can add the starting resistance by using the starter handle, so that we are reducing the starting current to the armature circuit. That is the main function. Other three functions are, there is load is decreases. At the time also it will release the starter handle. Any problem in the field winding, any field is open, at the time also it will release the starter handle. And also over voltage protection. If over voltage occurs, the more current will flow, it become electromagnet. This coil is attracted, iron bar is attracted. At the time also it become demagnetized and release the starter handle. Right. So it will do the over voltage protection also. Now we'll see the description. L, L1, A, F, L2 are the 4 points of the 4-point starter. Line 1, line 2, armature and field. In a 4-point starter, NVR is connected in parallel to the field. In previous 3-point starter, it is connected in series. So field current coil, field current also affect the operation of NVR. Now it is connected in parallel. Any change in the field does not affect the NVR. Hence wide range of speed control is possible. Right? If you reduce the field winding, field current, that will not affect, so that we can go below rated speed and above rated speed also possible, because it is connected in parallel. In a 4-point starter, when the starter arm touches the start position, current flowing from the supply is divided into 3 different paths. One is flowing through the starting resistance and armature, another one through the field winding, another current through the NVR. It is divided into 3. One is starting resistance and armature, field winding and NVR. The function of NVR is to protect the motor against the no voltage or low voltage. That also we already discussed. And also the function of OLR is to protect the motor against overload. If any overload occurs, that also protected by the OLR. Since in a 4-point starter, the NVR is independent of the field circuit. It is connected parallel. Previously it is connected series. So the DC motor may be over speeded if for any reason there is a break in the field circuit. So therefore starting the field circuit should be checked if there is any open circuit. Previously in 3-point starter, the field winding NVR connected in series. So any problem in the field winding, automatically NVR disconnect the supply. Now it is connected in parallel, so if any overload occurs, it will not affect the NVR operation. So we need to check whether there is any open in the field winding before starting the motor. So subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.